17 gigabytes VRAM, 27B params, Apache 2.0. A year ago, running the model this capable on a single consumer GPU was science fiction. 2 years ago, even a 7B model struggled with basic reasoning tasks. Today, you can download a 27 billion parameter multimodal model, run it on hardware you probably already own, and never send a single byte to the cloud. This is Qwen 3.8 27B. Benchmark numbers that put it uncomfortably close to models 10 times its size. On August 14th, Alibaba's Qwen team dropped Qwen 3.8 27B. It's a 27 billion parameter dense model, Apache 2.0 license, a native vision encoder that processes images and video without adapters, a 262K token context window, extendable to 1 million, and benchmark numbers that, if they hold up to independent scrutiny, put it uncomfortably close to models 10 times its size. This is the model the open-weight community has been waiting for. This isn't Alibaba's first shot at a capable small model. Qwen 3.6-27B came out earlier this year and was already solid for its size class, but 3.8 is a different beast. The Qwen 3.8 family also includes a 2.4 trillion parameter flagship called Qwen 3.8 Max. That one needs a GB300 NVL72 rack to serve. It's the kind of model only cloud providers can run. The 27B is the version you can actually download and run on your own hardware, and that distinction matters more than any benchmark score. The context here is important too. Meta released Llama 4 Scout earlier this year. Mistral has its own small model line. Google shipped Gemma 3. The race to build the best dense model under 30B parameters is real. Everyone wants a model that's small enough to run locally, but capable enough to be actually useful. Qwen 3.8 27B is Alibaba's answer, and it's a strong one. Under the hood, the architecture is where things get interesting. Most transformer models use full quadratic attention on every single layer. That's O of n squared computational complexity. For a 262K context window, that gets expensive fast. Qwen 3.8 27B takes a different approach. It uses hybrid attention. 3 out of every 4 attention sublayers are gated DeltaNet. That's linear attention, O of n instead of O of n squared. The model processes long context dramatically faster without burning through VRAM. The remaining quarter uses full gated attention for the tasks that actually need it. It's a practical engineering trade-off, and it works. There is also multi-token prediction built in. An auxiliary head predicts multiple future tokens simultaneously during training. At inference time, this enables speculative decoding. The model drafts several tokens, then verifies them in parallel. That gives you a 15 to 25% throughput boost on supported hardware. Not a gimmick, real speed improvement on real workloads. And then there's the reasoning _effort dial. This one's subtle but important. You can control how much compute the model spends thinking. Turn it down for fast responses on simple tasks. Turn it up for harder problems that need deeper reasoning. It's not just a temperature slider. It actually changes how many inference steps the model takes. That kind of fine-grained control over the speed-quality trade-off is rare in open-weight models. The vision encoder is natively integrated, not bolted on with adapters like some other models. It processes images and video streams directly into the embedding space. That means better multimodal understanding and fewer artifacts when the model is working with visual inputs. Now the numbers. And this is where you need to pay close attention. Terminal Bench 2.1 scores 73.0. SWE-bench Pro hits 61.7. LiveCodeBench V6 reaches 90.3. OSWorld-Verified comes in at 84.3. Deep SWE lands at 42.2. Those are strong numbers for any model. For a 27B dense model, they're remarkable. The model outperforms Meta's Muse Glimmer across all 8 benchmarks they share, and it surpasses Claude Opus 4.6 on 15 of 19 overlapping tests. That's not a typo. A 27B model beating Claude Opus on most coding benchmarks. But here's the asterisk you need to see. Every single one of those benchmarks is Alibaba's own. There's no independent replication yet. The evaluation protocols differ from how other labs run their tests. GPT 5.6 and Claude still score higher on several hard coding and scientific reasoning tasks, so take the Beats Claude headlines with a serious grain of salt. The numbers are impressive, but they're unverified, and that distinction matters. Here's what's actually interesting about this release. It's not the benchmark scores, it's what those scores mean for the economics of AI. A single RTX 4090 handles the 4-bit quantized version, 17 gigabytes of VRAM. Community GGUF builds hit 80 tokens per second on two 4090s. That's 34 gigabytes total, the kind of hardware a serious hobbyist or small team already has. The hosted price tells the other half of the story. 45 cents per million input tokens, 320 for output. That undercuts most hosted alternatives. And the weights are Apache 2.0. You can deploy it anywhere, modify it for your use case, build products on top of it. No API key required, no usage limits, no safety review gate blocking your deployment. This changes the conversation. It's not about whether open models can match closed models on every benchmark. They can't, not yet. It's about what happens when the gap gets small enough that the trade-off shifts. When a model good enough for most real-world tasks costs nothing to run after the initial hardware investment. When you control the data, the inference, and the deployment, that's a different kind of progress, the kind that doesn't require a cloud account or a venture-backed budget. Think about what this enables. A startup can build an AI product without paying per token to OpenAI or Anthropic. A researcher can run experiments without worrying about API costs. A developer in a country with restricted cloud access can run a capable model locally. The 27B size hits a sweet spot, big enough to be genuinely useful, small enough to actually run. And the Apache license means the ecosystem can build on it without asking permission. So where does this land? It's not the best model in the world. GPT 5.6 and Claude still lead on the hardest tasks, but it might be the most important model released this month. A 27B model that fits on your desk, runs under your control, gets you 80% of the way to frontier performance. That's not a consolation prize. That's a structural shift in who gets to build with AI. Check the benchmarks yourself when independent scores land, but the direction is clear. The local tier just got a lot more interesting, and Alibaba just showed that the gap between closed and open is narrower than anyone expected.